Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series B.Arc Semester 1 Mathematics Lecture 3. In this lecture, we are going to discuss some of the important concepts in mensuration like area of plane figures, computation of volume of solids. Area of plane figures are very important in the area of architecture to measure and construct the desired area. Computation of volume of solids is also an important concept in the field of architecture. To construct any building, amount of material required can be calculated using this volume of solids. We will be discussing in this lecture some basic concepts to compute volume of some important solid shapes. Let us come to the area of plane figures. The very basic plane figure is square. You know, area of a square can be calculated by multiplying the sides 2 times. So, if you are given a square of side A, then multiplying that side by itself will give area of the square. Then rectangle. In square, all the sides are equal, but in rectangle, opposite sides are equal in length, then all the angles are equal to 90 degree. In square also, all the angles are equal to 90 degree. In rectangular also, all the angles are equal to 90 degree. But the basic difference between square and rectangle is opposite sides are equal in length in rectangle, but in square all the 4 sides are equal. Here, to find the area of a rectangle, length of the rectangle and breadth of the rectangle are multiplied, so that you will get area of the rectangle. Then circle. You know, the area of the circle can be calculated by the formula pi area is equal to pi r square, where pi is a constant whose value is 3.14. Then r is the radius of the circle. That pi can be in here the r is radius. Radius can be in centimeter, millimeter, meter, kilometer. In any of the length measuring unit, radius can be given. So, if the radius is known, you can calculate the area of the circle. Next, ellipse. You know, ellipse is a bulged circle. Radius of the ellipse will not be equal. You know, in ellipse, 2 types of axes are there, that is major axis and minor axis. The term major is used to denote the larger length. The term minor is used to denote the smaller length. So, here radius of the major axis radius is denoted as r1, then r2. Minor axis radius is denoted as r1. So, area of the ellipse can be computed using the formula pi into r1 into r2, whereas in circle this is equal to pi r square, because in circle radius is only 1, then the radius is equal. Radius is the length connecting any point on the circumference of the circle to the center of the circle. So, radius is the length connecting any point on the circumference of the circle to the center of the circle. So, radius is same or common for a circle. So, area of the circle is computed by the formula pi r square, but in ellipse one side is bulged, then other side is contracted. So, that two kinds of radius exist. The major radius is denoted here as r2, then the minor radius is denoted here as r1. So, area of the ellipse is calculated using the formula pi into r1 into r2. Then the next shape, next basic and important shape in the field of area of plane figures is triangle. There are many types of triangle. For each triangle, different formula are there to calculate the area of the triangle. Here in the here we took the equilateral triangle as the first case. Equilateral triangle means all the three sides are equal. That's why it is called as equilateral triangle. Area of this equilateral triangle can be calculated using the formula area is equal to square root of 3 by 4 into a square, where a is the length of the any one side. Here in equilateral triangle we know that all the three sides are equal. So, any one side length is taken and it is squared, and that value is producted with the square root of 3 by 4. Here angles in it got the name triangle because three angles are involved in obtaining the shape. That's why it got the name triangle. So, three sides and three angles, all the sides are equal here, so that it is called equilateral triangle. All the angles are equal, so that it is called equilateral triangle. Then you know that in a triangle sum of all the three angles are equal to 180 degree. In a triangle sum of all the three angles are equal to 180 degree. Here in equilateral triangle all the angles are equal. So, the value of each angle in equilateral triangle is equal to 60 degree. This is the another important shape in two dimension or a plane. Next type of triangle is a right angle triangle. Area of this right angle triangle is obtained by the formula half into b into h, where b is the base of the triangle and h is the height of the triangle. This is called right angle triangle because the angle connecting the height and base is equal to 90 degree, otherwise is equal to right angle. So, that it is called as a right angle triangle. For this right angle triangle, Pythagoras theorem can be applied, which says that sum of square of any two side is equal to the square of other side. Sum of square of the two sides is equal to square of the other side. This theorem is applicable to this right angle triangle. Area of this right angle triangle is obtained by the formula half into base into h. Then the next type of triangle is obtuse triangle, obtuse angle triangle. Area of this obtuse angle triangle is again calculated by the same formula as the right angle triangle, half into base into height, where base is this side, then height is this side, multiplying these two and dividing the product by 2 will give area of this obtuse angle triangle. The next type of triangle is isosceles triangle. In this isosceles triangle, same formula can be used, like half into b into h, where b is the base, h is the height. Instead of this half into base into height, you can use this formula also, that is 2 into base into sine c. So, this is the other type of formula to calculate area of isosceles triangle. So, in triangle itself we have seen isosceles triangle, obtuse angle triangle, right angle triangle, equilateral triangle. These are all the types of triangle we have seen in this discussion. Next, we will move to four-side figure, four-side plane area. The four-side plane area is trapezoid. You know, square is also a four-side plane area. Rectangle is also a four-side plane area. In that square and rectangle, all the four angles are equal to 90 degree, but in this trapezoid the angles are not equal to 90 degree and also not equal. So, here you got the opposite sides are parallel. That is the basic thing about this trapezoid. Area of this trapezoid can be obtained using the formula half into height into a into b. So, this is the formula used to calculate area of a trapezoid. The next four-side irregular shape figure is rhombus. Here the diagonals are produced, diagonal d1, diagonal d2. So, product of that, half of the product of that two gives area of the rhombus. Then the next thing is parallelogram. In parallelogram, the area can be obtained by base into height. Then scalene triangle. This scalene triangle is used in some important areas in the area calculation. Area of this scalene triangle is obtained by the formula square root of s into s minus a into s minus b into s minus c, where s is equal to a plus b plus c by 2 is the formula used to calculate the area of the scalene triangle. Here ABC are the length of the three sides of the triangle. These are all the important two-dimensional plane figures used in the field of architecture. The next thing is regular n-gon. Here this n represents the number of sides in that gon. If there is more than 4, you can call that as polygon. If there is 5 sides, you can call that shape as pentagon. If there is 6 sides, you can call that shape as hexagon. 8 sides, octagon. More than 8 sides, then you can call that as n-gon. This n is equal to number of sides in that two-dimensional figure, where a is the length from center to the corner. So, each side has 2 ends. That 2 ends, if that 2 ends are connected to center of that regular shape, then the distance of the end to the center is equal to a. N is the number of sides. Then the area of this for octagon, number of sides is equal to 8. So, half into 8 gives 4. Then sine 360 by 8 gives 45. So, for the octagon shape, area of the octagon is calculated by the formula 4 sine 45 a square. So, this is the thing about regular n-gon. Then the next figure in the 2 dimension is sector, where sector is a small area in a circle. That sector makes some angle with the center. If that angle is 60 degree or any degree in general like theta, then area of this sector can be calculated by the formula pi r square by 360 degree into theta. Here in this diagram, the sector subtends an angle 60 degree. Instead of this theta, if you substitute 60, then you will get 6 here, 360 into 60. So, this formula will reduce to the form pi r square by 6. So, like that you can calculate the area of a sector carved out from a circle. Area of a circle, you know, pi r square, then total angle in a circle is equal to 360 degree. Then the total area of the circle divided by total angle in the circle gives area per each degree. So, area per each degree into number of degrees gives the area of the sector carved out from a circle. This is the next important shape in 2 dimension plane figures. Then surface area of a cube. Surface area of a cube. Next important plane surface here is total surface area of a cube. You know, a cube is made up of 6 faces, 4 sides, then top one side, bottom one side. So, 6 faces are there. So, each face area is a square, totally 6 faces. So, 6 into a square is the total surface area of a cube. This is a 3 dimensional area. The next one is curved surface area of cylinder. You know, in cylinder 2 types of surfaces are there. One is curved surface area, then 2 flat surface. At the top one flat surface and the bottom one flat surface. So, the curved surface area of the cylinder is calculated by the formula 2 pi r h. This is the formula used to calculate the curved surface area of the cylinder. The next thing is cuboid. You know, cuboid also has 6 faces, but the area of each face are not equal. Here these 6 faces, out of these 6 faces, 2 faces has equal areas, like the top surface and the bottom surface. Top face or the bottom face has got equal areas, and this face, a face opposite to this face has got equal area. So, 2 into sum of the 3 faces, sum of area of the 3 faces will give surface area of a cuboid, total surface area of a cuboid. So, in this discussion, so far we have seen many 2-dimensional shapes and 3-dimensional shapes, how various formulas to calculate the area of different shapes and different things. We will apply all these concepts in the following figure. In this figure, we are asked to find the area of the figure. This figure is made up of many number of squares and rectangles. First, what we need to do is we need to identify how many number of squares and how many number of rectangles are there. Then you can keep the area of each square as some unit. Then you can apply that to the other part of the figure. Then we will get the total area of the figure. So, we will apply the area formula of square in this problem. Solution to this problem. Solution. First we need to find the number of shapes in that figure. So for that what we need to do is we need to fill the missing letter in this thing. The missing letter is left hand side is also 8 units. Here you got 4, 2, so 4 plus 2 was 6. So here you got a missing thing. So 8 units. 4, 2, 2, totally 8 units are there in this left hand side. Out of that 8 units, you got one unit is cut out. So we got 8 minus 4 minus 2 is equal to 2 units. So enclose this figure in 8. Here also you are given 2, missed a 2 unit. Then here also you missed 2 unit. Then here you missed 3 unit. So totally this is a square of 8 into 8. So 8 into 8, which is equal to 64 unit square is the total area enclosed in that figure. In that 64 u square, top cutout is 2 into 2. Top cut is equal to 2 into 2. Here this 2 is cut. So this 2 into 2 is the top cut. Then left cutout. Left cutout is equal to again 2 into 2, which is equal to 4 unit square. This is also 2 into 2 is equal to 4 unit square. So here the left cutout is 2 into 3, 6 unit square. In left cutout 2 into 3, 6 unit square. Then lower cutout is equal to 2 into 3 is equal to 6 unit square. So lower one is here, this is 2 and this is 3. So 2 into 3 is equal to 6 unit square. So area of this figure, total area of the figure is equal to 64 minus 4 minus 6 minus 6. So this 4 unit square, 6 unit square, then this 6 unit square are all cutout areas in the figure. Total area is 64 unit square. So manipulating this, we got total area of the figure is 48 unit square. This is how you can apply the concept of area of a square in the given example. The next example. So this figure is made up of square, rectangle, then four side shape, like that many shapes are included in this figure. Here in this example you are asked to find the area of the figure given below. What you need to do is first you can find the area of the square, then area of the triangle given, then sum all the areas, you will get the total area of this figure. So first to find out what are the familiar shapes exist. Central square, the figure consists of central square, then 5, that central square shape is 5 into 5, then 3 triangles, one on top with base is equal to 5 and h is equal to 3. The first triangle as base B is equal to 5, H is equal to 3, and one on the bottom. The top triangle is this one, then bottom triangle is base 5 and H is equal to 2, and trapezoid with an upper base trapezoid with an upper base 4 and a lower base 2 and height 2. These are all the shapes included in the given figure. So, a central square, then 3 triangles, one on the top, one on the bottom, one on the right hand side, and you got a trapezoid of upper base 4 and lower base 2 and height is equal to 2. Now, find the area of the each shape, sum all the areas, you will get the total area of the given figure. So, first square is equal to, area of the square is equal to 5 into 5, which is equal to 25 units square. Then top triangle area is half into base into height, which is equal to 7.5 units square. Then bottom triangle formula, half into base into height is equal to 5 units square. Then right triangle as base 3 and height 4 is equal to 6 units square. Then trapezoid 4 plus 2, sum of 2 bases into height over 2 is the formula of trapezoid, that is half into height into base 1 plus base 2 is equal to 6 u square. This is the trapezoid. So, sum of all these areas like 25 unit square plus 7.5 unit square plus 5 unit square plus 6 unit square, then one more 6 unit square. Sum of all these things gives 49.5 unit square. So, this is the total area of the given figure. So, in this problem we found the area of the given figure. Volume of a cuboid, this is the formula to calculate volume of a cuboid. Then volume of a cube, volume of a cylinder pi r square h, volume of a cone 1 by 3 pi r square h, volume of a sphere 4 by 3 pi r cube. Then so like that volume of different shapes can be calculated. So, in this lecture we learnt various formula to calculate the area of different shapes and volume of different shapes, area of 2-dimensional figures and volume of solid shapes. We learnt all these things. Then we practiced some examples to find the area of a shape which has many different shapes like square, triangle, trapezoid, like that different shapes are joined together and one plane area is obtained. How to find the area of that shape is learned from this lecture. These are all the concepts we learned from this lecture. So, after listening to this lecture you can answer the following questions. Find the volume of a sphere of radius 4 centimeter. Find the total surface area of a cube of side 5 centimeter. find the radius of the circle whose area is 20 centimeters square. Like that, these questions can be answered after listening to this lecture. Thank you.